Let's have a go at this geometry problem from the 2017 Senior Maths Challenge. Two right-angled triangles are drawn inside a square as shown. The lengths of the perpendicular edges of the larger triangle are 15 and 20. We are asked to find the shaded area. Pause the video now if you want to have a go by yourself before I present the solution. We are going to calculate the shaded area by first working out the area of the square and then subtracting the area of each triangle. The area of the square is simply the square of its side length, which we already know is 20. So we get 20 squared, or 400. To work out the area of each triangle, we are going to use the formula half base times height. We already know that the base and height of the larger triangle are 15 and 20 respectively, and so its area is 1/2 times 15 times 20, or 150. However, we know neither the base nor the height of the smaller triangle. At first it appears that the only thing we do know is that the length of its hypotenuse equals the side length of the square, i.e. 20. But if we examine the diagram more closely, we will see that the two triangles are similar triangles. That is, they have the same angles. If we let the bottom angle of the larger triangle be x, then, using the fact that the angles in a triangle add up to 180, we can work out that the top angle is 90 degrees minus x. Then the rightmost angle of the smaller triangle must be x, because the angle at the top right corner of the square is a right angle. Finally, the leftmost angle of the smaller triangle must then be 90 degrees minus x, since angles in a triangle sum to 180 degrees. Now observe that the three angles in both triangles are 90 degrees, x, and 90 degrees minus x. They have the same three angles, and so are similar triangles. Pairs of corresponding sides of similar triangles are related by a common scale factor. We can work out the scale factor of the similar triangles using the ratio of their hypotenuses. The hypotenuse of the smaller triangle is 20, and the hypotenuse of the larger triangle can be worked out using Pythagoras' theorem as 25. So the scale factor is 20 over 25, which simplifies to 4 over 5. That means if we take the length of a side of the larger triangle, then the length of the corresponding side of the smaller triangle is 4/5 of that length. So the lengths of the remaining sides of the smaller triangle are 4/5 of 15 and 4/5 of 20. i.e. 12 and 16 respectively. Hence the area of the smaller triangle is 1/2 times 12 times 16, which equals 96. Finally, the shaded area equals the area of the square minus the area of each triangle. 400 minus 150 minus 96, which equals 154. So the answer is 154.